Hello.
Good evening.
Good evening. Hari Raghav, how are you?
I'm fine, ma'am.
Sanjay, how are you?
Fine, ma'am.
Sai Kalyan.
I'm fine, ma'am.
All of you have decided to keep your cameras off for today.
Ma'am,
When
I'm
you
having
go
power cut, ma'am.
You are having power cut. Oh God. Okay. So for others who are not having power cut, please switch on your camera. When you go to school, do you wear a face shield, dark face shield, so that the teacher doesn't see you? I feel the same. All of you with your mask on, I don't see anyone. If you're having power cut, I understand. But if you're not having power cut, then you should switch on your camera. Okay, so we have been waiting now. Nobody is reported. Still only 4 participants. What to do? So we'll revise. We'll start revising. So all of you who are present now, today and tomorrow is only revision day. So today I want to revise only solutions, and tomorrow I want to revise only alkyl halides, so that you do your test properly. Okay. Last test of alkyl halide did not turn out very well. Yes, tell me.
Firstly, we have the test on the end of the month, right? We're talking about that test, right, Mama?
Yeah, I'm not sure of the dates, but yes, I know the question paper is ready, so I know that there is going to be a test. So now from there are few days there will be no classes. So now today and tomorrow only we have to revise. So today I want to revise solutions. You will have one test on solutions separately, and then there will be a test on solutions as well as alkyl halides mixed.
Actually, they have only given us a schedule that we'll have both the things together.
What is it? I didn't get it.
Actually, we have got a schedule that we'll have solutions and alkyl halides and arynes together on the end of the month.
Yeah, your test will be okay. So maybe earlier there was a plan to have solutions separately also, but anyway, now you will definitely have a test on alkyl halides and solutions. So we will revise solutions today, and then we'll revise alkyl halides. Whatever doubts you have, you should ask. So all throughout this chapter, there were a lot of new formulae that we learned. So make a list of those formulae. My suggestion is write down these formulae on a foolscap paper and paste it in front of your study table, so that you are always aware of the formulae properly. Okay. So first formula that we learned was mass by mass percent. Okay, what is mass by mass percent? It is mass of solute divided by mass of solution into 100. Okay. Then we learned volume, mass by volume percent. What does that mean? It means mass of solute divided by volume of solution. Oh, sorry, solute only. Mass of solute divided by volume of solution into 100. In fact, I wanted to ask you these questions. So when a few more come, then I will start asking. Then third is what? Third is mole fraction. What is mole fraction? Mole fraction is mole fraction is what? Tell me, what is mole fraction? Anybody who is present? Who else has come now? Vaishnavi has come. Right. Anybody who knows this? Sai Kalyan, tell me what is mole fraction?
number of moles by number of moles. Number of moles of
what?
solute divided by number of moles of solute by number of moles of solvent.
Yes, number of moles of solute
By number of moles of
divided by, yeah.
the number of moles of solute plus number of moles of solvent.
Yeah, let me make it easy. It is NB upon NA plus NB. Right now you know what NA and NB are, so I don't have to write this whole thing. Then fourth one is molarity. What is molarity? My, this is troubling. Just 1 minute. I'll go off and join again. Share screen. Okay. So what is molarity? Who will tell me molarity? Sanjay, do you remember what is molarity?
Moles of solution, moles of solute by mass. Moles of solute divided by volume of solution.
Yes, moles of solute divided by
volume of solution.
Divided by volume of solution.
Volume of solution.
Volume of solution in liters, right? Very good. So that is molarity. Now somebody else tell me what is molality.
Ma'am, can you show the before slide?
Yes.
Yes, ma'am.
What is molality?
Ma'am, number of moles of solid by mass of solvent in kilograms.
Yes, number of moles of solute divided by mass of solvent in kilograms. Very good. Then sixth one is I think that's all. 1, 2, molality. Yeah. What was the next thing we learned? That is vapor pressure of a solution. What is the vapor pressure of a solution of two miscible liquids?
Vapor pressure is inversely proportional to 1 by intermolecular force of attraction.
Yeah, so vapor pressure of a solution of two miscible liquids is P total, right? Was equal to PA plus PB, right? And to simplify, we also found PA. PA is equal, P instead of PA, we could write P0A into XA plus P0B into XB. Right? That is how we calculated
So here,
vapor pressure for ideal, right? What?
Can you say what's PA and PB?
PA is a partial pressure of solution A and PB is a partial pressure of solution B. So some P total vapor pressure, total vapor pressure of the solution is equal to the sum of partial pressure of the components. And partial pressure of a component is equal to the product of its mole fraction and the vapor pressure of the pure solution, pure solvent, pure component. Okay. Then we learned the seventh, we learned Henry's law. So this was Raoult's law. Right? Then it was Henry's law. What was Henry's law? Pressure is equal to KH into X. What is KH? KH is Henry's constant. So pressure, vapor pressure is proportional to Henry's law. This is Henry's law. Vapor pressure is proportional to the mole fraction of the solute or whatever, mole fraction of the vapor of the solution that you are trying to find out. Okay. So to remove the proportionality constant, we put KH. So P is equal to KH into X. You can say solubility. Solubility of a gas in terms of its mole fraction. So it is equal to, pressure is equal to the mole fraction of the gas is not into Henry's constant. Okay. That is 7. Now the eighth one, after that, the eighth one was that one was lowering of vapor pressure. So for that, what was the formula that we were using? P0 minus PS upon P0. Relative lowering of vapor pressure is equal to the mole fraction of the solute. So NB upon NA plus NB. That was eighth one. Ninth one was elevation of boiling point.
Ma'am, in here NB means?
NB is number of moles of solute.
Okay.
Right?
NA,
and Na is equal to number of moles of what?
solution.
Solvent. Okay. Elevation of boiling point. What was the formula? There were two you learned. Delta TB is equal to KB into M. That was simpler one. Then elaborate formula was delta TB is equal to KB is equal to KB into WB into 1000 upon MB into WA. Okay. WB is the mass of the solute and WA is the mass of the solvent and MB is the molar mass of the solute. That is ninth one.
Ma'am, 1 minute, ma'am. I'll call. So MB is molar mass, right?
Yeah, MB is the molar mass.
Ma'am, so WB and WA are masses of A and B, right?
B and WA are masses of solute and solvent. Everywhere where I write B, B is for solute, A is for solvent. Okay.
Yes.
Then the next one is the 10th one is depression of freezing point. Who will tell me the formula? Somebody? Vaishnavi, I didn't hear you at all today. Tell me the formula for depression of freezing point.
Yes, ma'am. Ma'am, del TF is equal to KF into WB by WA into N.
Yeah, KF into N, that is one, simple one. And the other one you said rightly is equal to KF into WB into 1000 divided by MB into WA. Okay, so that is depression of freezing point. And remember these formulae are for those solutes which do not ionize in solution. Okay, these are for which solutes? Those solutes which do not ionize in solution. Organic compound. If your solute is, this formula is applicable where? I think it is this formula is applicable when your solute is, you know, an organic compound. Organic compounds normally which they ask are like, for example, glucose, or it is sucrose, or it is urea, or it is benzoic acid. So such solutes, if they are there which do not ionize in solution, then we can write these formulae. Otherwise, we have to take care of what? Want of factor. We have to take care of want of factor. So 10. Now 11th one is osmotic pressure.
Ma'am, here KF means
Here KF is, tell me what is KF? Depression of freezing point, constant. It is a constant for depression of freezing point. Cryoscopic constant we call it. Let me write it. Cryoscopic constant. KF is cryoscopic constant. That value will always be given. It is a constant for a particular solvent. Similarly, KB is ebullioscopic constant. Okay. In the previous slide, you see KB. KB is what? Ebullioscopic constant. So your all your questions, they will be based on this. All your questions will be based on this one. These formulae. Osmotic pressure. Who will tell me osmotic pressure? Hari Raghav, can you tell me what is the formula for osmotic pressure?
Ma'am, is it pi is equal to MRT?
Pi is equal to not CRT. You can say CRT. Okay, C is the concentration, or you can say pi.
Ma'am, is it a molar concentration?
Yeah, molar concentration. N by V RT. Right? You can also say it is equal to N by V RT. Sometimes it is written as pi V is equal to nRT. They all are same.
ma'am, so here R and T means
What is it? The value R.
R and T.
R is a gas constant.
Okay.
And the gas constant value is for most of your calculation, the value R is equal to gas constant.
Okay, ma'am. Constant value, ma'am.
And that is equal to 0.0821 liter atmosphere per mole. Okay.
Okay. Ma'am, T.
What is it? T is
T.
temperature in Kelvin. Right? N is the number of moles. V is the volume of the solution in liters. Okay, in osmotic pressure only we take, in all other cases we are taking mass of the solvent, but in osmotic pressure we take the volume of the solution.
Yes.
Okay, so that is for osmotic pressure. Then after this we did want Hoff factor. So
12th one.
12th one is want Hoff factor. So for want Hoff factor, I is equal to number of particles before, not before, after. Before is number of particles before dissociation divided by number of particles. Sorry, here this is after. I keep writing this way. Number of particles after dissociation, and here number of particles before dissociation. Before dissociation. Okay. Or you can find, or the easy way of calculating AI is that you can put it in your all these formula. Like you can say delta T B is equal to I into KB into WB into 1000 divided by MB into WA. Right? You can put a I here. Or you can say pi is equal to I into C into R into T, I into CRT. So you can find I. So that is want Hoff factor. You can calculate it in any way. Another formula for I which we sometimes use is I is equal to abnormal we had done it somewhere. Don't add that formula. This is enough. Then the last part of our chapter.
Ma'am,
That
so
is,
the last I is equal to abnormal, ma'am.
no, last I, I should have written it here. It is, the experimental molar mass divided by theoretical molar mass. What you find experimentally divided by theoretical. Okay, that is also I, but but I don't want you to write that because I want you to use these formulae. This is much easier to find the answer. Okay, that is why I rubbed it off. Then the next one is degree of dissociation. So degree of dissociation, it is alpha is equal to I minus 1 upon n minus 1. Okay, I is the Van 't Hoff factor which you will calculate using one of the formulae there. And n is the number of particles complete total which you would get on complete. Huh?
The cell.
Degree of dissociation alpha is equal to I minus 1 upon n minus 1. N is the number of particles which would be formed on complete dissociation. That is n. Then 14 is degree of association. Right? What is degree of association? I is equal to 1 minus alpha by 2. For degree of association, we use this. I is equal to 1 minus alpha by 2. Okay, so these are the formulae that we should use in this chapter. So once you are thorough with the formulas, you should be able to answer all the questions based on anything. I mean, all these questions, numericals are all based on this. Okay. Other than this, you have to learn those graphs of ideal and non-ideal solutions to identify whether you are getting minimum boiling mixture or maximum boiling mixture. Which are the compounds which form, which combination of compounds form positive deviation, which form negative deviation. All those lists you should make and learn it and keep. Do you want me to give those lists once again?
Yes, ma'am.
So here ideal solution, common ones I am giving only. Ideal solution. Here there is solution, and this side is non-ideal. Right? Ideal and non-ideal solution. Here I have those with positive deviation, and here I have those with negative deviation. So for ideal solution, two examples for ideal solution, benzene and toluene. Right? Ideal solutions are easy to make out. N-hexane and N-heptane. They are similar looking compounds. Okay. Methanol plus ethanol. They will form ideal solutions. Positive deviation. Water plus ethanol. Right? Water plus methanol. They will show positive deviation. Negative deviation, water plus nitric acid, HNO3. I told you when one of them is an alcohol, then positive.
Ma'am, actually water plus ethanol is for benzene plus toluene.
Water plus nitric acid is for a negative deviation.
No, ma'am. I'm asking about we have methanol plus ethanol here, no, third one. But if not given anything for the positive one.
I didn't understand your question. Methanol and ethanol are ideal solutions. But water plus methanol or water plus ethanol is positive diffusion.
Okay. Okay. Yes.
So chloroform plus acetone, that is negative deviation. Okay. Now we will do a few questions. Now, what I suggest is I'm doing some questions from, there is, there are on the internet, you can download something that is exemplar problems. Exemplar problems on solutions. Okay, so when you type this, you will get problems on solutions which are exemplar problems. Okay, so these exemplar problems are very, very useful. They are very good. And they are there, exemplar problems are there on all the topics. And this is by NCERT. Okay, so there is a book on exemplar problems. You can download the book online from NCERT website, and it has a lot of questions. Some of those questions I have copied here, and we will do them. Okay, so this is the remaining of the questions that we were doing in the last class. Let us do those, and then we will do exemplar problems. Okay, so today it is only revision. So doing these questions will help you to revise. Now here the question is, ethylene glycol is used as an antifreeze in the cold climate. Mass of ethylene glycol is given, 4 kilograms water to prevent it from freezing at -6. Okay, so depression of freezing point is how much? 6. Okay, 0 minus -6 is 6. So what is the formula that I'm going to use? It is ethylene glycol, so it is an organic compound. So how will I do this question? Tell me. So it is formula will be delta TF is equal to KF into WB upon MB into WA. I have not written 1000 here because the mass of the solvent is already in kilograms. So just put the values here. So this is equal, this is 6 is equal to KF is 1.86 into WB, mass of the solute is what we have to find out, WB, upon molar mass of the solute, that is 62, into mass of the solvent is 4 kilograms, 4. So if someone can do this calculation quickly, what is WB equal to? Quickly, let me see who tells me quickly. You shouldn't take more than 1 minute to do this question. So it should be 62 into 4 into 6 divided by what? Divided by 1.86. So what will you get?
No, we are getting something 275.26.
No. You are making some.
Ma'am, first we should add 62 into 4 into 6 divided by 1.86. Ma'am?
What is it? WB.
Ma'am, so we should. Ma'am, so we should do it like 62 into 4 into 6 divided by 1.86, right?
Yes. 24 into 62
that-
divided by 1.86.
That's what we are getting.
Answer should be, when I did it, I got some other answer. Somebody else try. 62 into 24.
Ma'am, we are getting 800.
Yes, 800. Answer is B.
Yes, ma'am,
Got
800.
it? WB is
Yes, ma'am.
equal to 800.
Yes, ma'am, 800.
Now, depression in freezing point of 1 molar urea, 1 molar glucose, and 1 molar NaCl are in which ratio? Okay. So 1 molar urea will cause how much depression? Equal to 1 mole. This will also be equal to 1 mole, but this will be equal to 2 moles because this will dissociate to give 1 mNa plus 1 mCl minus. So this will be equal to 2. So what will be the ratio? 1:1:2, right? Answer is 1. If you have not understood, please ask. 1:1:2. Now the next question, 12th. See carefully. The 12th question, what is the answer? First, understand the question. The solution that forms maximum boiling azeotrope, which will have a maximum boiling will be of a one which will have the lowest vapor pressure. Lowest vapor pressure is which one? Which causes negative deviation. So just now I gave you the list. Which one will cause negative deviation? Tell me. A, B, C, or D. Look at the list and tell me which will cause negative deviation.
Ma'am, C.
C. Benzene and toluene will be ideal, right? This will also be ideal, right? Carbon disulfide and acetone, I am not sure. Carbon disulfide and acetone. It is definitely acetone and chloroform. Okay, carbon disulfide and acetone also maybe, but I think it is a positive deviation. Okay, now this is another type of questions which are very misleading and difficult to answer. I don't know whether in 11th standard are you used to doing these questions of assertion and reasoning, or have you learned doing them? Tell me. Vaishnavi, have you done these questions in class 11? Assertion and reasoning questions. Have you done?
Yes, ma'am. Assassin reason you have done, ma'am.
We have done.
11th we have done.
11th you have done. So you understand. So if there are two statements given there, so if both the statements, first you have to see whether if both the statements are correct and statement assertion, the reason is a correct reason for the assertion. That means they are both related and the second statement gives the explanation of the first. Then it is A, right? If both A and R are correct and R is the correct explanation of A. Then second is if A and R both are correct, but R is not the correct explanation of A. Then A is true, but R is false, and A is false, but R is true. So we have to decide A, B, C, or D here, right? For assertion and reasoning. Now the first one, now these are very, very misleading. You have to first look at each statement independently and first decide whether they are both correct or not. Which one is correct? So first let us go by that. So first statement, when a blood cell is placed in hypertonic solution, it shrinks. Tell me, anything which is placed in hypertonic solution. Hypertonic means what? Vaishnavi, what is the meaning of hypertonic? Today I am not hearing your voice at all. What happened today?
Ma'am, poor network issues, ma'am.
Poor network. Okay.
I'm having a
And
power cut in my area.
oh, so many people are having power cut in Chennai today.
I guess so, ma'am.
Okay. Okay. So, Sai Kalyan, what is
Yes,
the
ma'am.
meaning of hypertonic solution?
Miss, solution which shrinks any substance.
Yeah, so which has a higher concentration
Hypertonic
of the
solution.
two solutions. Yeah, if there are two solutions separated by a semi-permeable membrane, the solution which is higher concentration is a hypertonic solution, right? So when a blood cell is placed in a hypertonic solution, what will happen? The liquid from the cell will move out and the cell will shrink. So assertion is correct. All right, assertion is correct. And blood is isotonic with 0.09 solution sodium chloride. This you don't know, but I am telling you the concentration of blood is 0.09. Okay, so it is 0.09%. So this is also correct. Both are correct, but there is no relation between this and this. Okay, so why does a blood cell shrink in a hypertonic solution? Because when the cell membrane acts as a semi-permeable membrane and the solution from the cell moves out because it is there's a movement of solvent from dilute to a more concentrated solution. So the cell shrinks. So these two statements are correct, but they don't give explanation. B does not explain A. So what should be the answer? Both A and R are correct, but R is not the correct explanation of A. So here the answer should be B. The answer is B. Now the next one. Aquatic species feels more comfortable in winter than in summers. So I told you, aquatic life, fishes are more comfortable in cold water than in hot water, right? That is true. And solubility of gases increases with increase in temperature. No, the solubility of gases decreases with decrease in temperature, right? So A is right, correct, and B is false. So A is true and R is false. So answer here is C. When you increase the temperature, what happens? The solubility decreases. That is why fishes are more comfortable in winter than in summer, because in winter, more oxygen dissolves in water. Then azeotropic mixture is formed only by non-ideal solutions. Right? This is true. Boiling point of a azeotrope is either higher than both components or lower than both components. So this is also true. But this does not explain this one. Okay, why is azeotropic formed only by non-ideal solutions? Because the vapor pressure of the mixture is always in azeotropic mixture, the composition of the vapor is always different from the composition of the solution. Azeotropic mixture. So here they don't explain each other. So this is B. Then soft drink and soda water. Soft drink and soda water bottles are sealed under high pressure, isn't it? True. This is true. Dissolution of gas in liquid is an endothermic process. This is not true. So answer should be C. Okay, dissolution of gas in a liquid is not an endothermic process. Okay. Then on adding non-volatile solute to water, its vapor pressure increases. On adding a non-volatile solute to water, does the vapor pressure increase? No, the vapor pressure decreases. So first one is wrong. The second, relative lowering of vapor pressure is colligative property. So this is true. So A is false, but R is true. So that means this answer should be D. This I just collected a few questions so that you can understand how to go about A, B, C, D. So one choice is A, one is B, one is C, one is D, like that. Okay, so that is how we have to answer these questions. Don't copy them. I'm going to send a list, a few questions on assertion and reasoning to you. I told you, you can download this exemplar problem. They are full, they have given lots of assertion and reasoning questions with answers, so you should try them out. Now there are some MCQs. Let us do those. Okay. Who will answer the first? Now, these are questions which all of you should be able to answer. So one by one, I'm going to put the question. You have to read and answer. Okay. So the first question, let me see who all are present. 6. 5 only have come today. Okay. Somebody answer this question, first one. Which of the following units is useful in relating concentration of solution with its vapor pressure? So vapor pressure is the vapor pressure related to mole fraction or parts per million or mass percentage or molality? What is the vapor pressure of a solution related to? Tell me. Anybody?
Molality.
Molality is not the vapor pressure. It is the boiling point, depression in boiling point, elevation in boiling point, depression in. It is mole fraction, isn't it? Relative lowering of vapor pressure is equal to the mole fraction of the solute. So solution lowering of vapor pressure is related to always the mole fraction. Okay, and all others, the two of them, elevation in boiling point and depression in freezing point, they are related to molality. Okay, lowering of vapor pressure is related to mole fraction, and elevation in boiling point and depression and freezing point, they are related to molality. Okay, on dissolving sugar in water at room temperature, the solution feels cold to touch. Under which conditions the following cases dissolution of sugar will be more rapid? Okay, so when you make dissolve, what is it?
Powdered sugar in hot water.
Very good. Powdered sugar. This is general knowledge. Powdered sugar in hot water. Okay. Then, at equilibrium, the rate of dissolution of a solid solute in a volatile liquid solvent is. Okay, rate of at
equal to
equilibrium.
rate of crystallization.
Yes, is equal to rate of crystallization. Very good. Then the next one. Maximum amount of solid solute that can be dissolved in specific amount of given solvent does not depend on.
Ma'am,
Is it pressure?
is it nature of solvent?
See, in a given solvent, so we are not changing the solvent.
Nature of solute.
See, maximum amount of a solid. So we are not changing the solid. So maximum amount of solid. Nature of solid decides the the colligative property here. How much solid I can dissolve in a liquid does not depend on. It depends on temperature, isn't it? Because when I increase the temperature, the solubility. It depends. It depends on the nature of the solute. Depends on what you are dissolving. So it depends on nature of solvent. You have to say which is not. You are all answering for which is it depends on. Don't forget this word not. So answer, it does not depend on pressure, because solids when we dissolve a solid in a solvent, pressure is not important. Pressure is important when you dissolve a gas in a solvent, in a liquid. So when you increase the pressure, the solubility of the gas increases. But when you increase the pressure, the solubility of a solid does not change. Solubility of gas increases, but solubility of solid does not change. Okay, so it is pressure, does not depend on pressure. It depends on temperature, it depends on solvent, it depends on nature of solute, but not on pressure. Okay, so all of you were giving correct answers, but I think you are not looking at not. Then low concentration of oxygen in blood and tissues of people living at high altitude is due to. Why is there low oxygen?
High atmospheric. Low atmospheric.
Low atmospheric pressure. Okay. Will the low temperature also affect? See, by low temperature also the solubility at low temperature, we don't talk about temperature at all. You know why? Because body temperature remains constant. So it is only low atmospheric pressure. Okay. Considering the formation, breaking and strength of hydrogen bond, predict which of the following mixtures will show positive deviation from Raoult's law. Which will show a positive deviation? Tell me. We have given, I gave you the.
Ma'am, is it option A?
Yes. When one of them is alcohol, you can always take positive deviation. Okay. Colligative properties depend on. What are colligative properties? Colligative properties depend on. Tell me. Somebody?
Ma'am, is that number of solute particles in solution?
Yes, it depends on number of solute particles. Does not depend on nature or physical properties or nature of solvent. It only depends on the number of solute particles. Okay, number. So if it is one which does not ionize, it is equal to the concentration. If it is ionized, then it depends on how many ions it forms in solution. Which of the following aqueous solutions will have highest boiling point? What does adding solute do to the boiling point? Boiling point increases, right? So now you tell me which of them will have highest boiling point. I can give you a hint. Highest boiling point will be of a solution which has maximum number of particles. All of them have same concentration, which will have maximum number of particles. Tell me here. KNO3 will have 2. Potassium and nitrate. Ammonium nitrate will have 2. Ammonium and nitrate. Sodium sulfate will have 3. Answer is sodium sulfate. Why? Because it will give 2 Na, 2 sodium plus 1 sulfate. This will give 1 sodium plus 1 hydroxide. So this will give 2, this will give 3. This will also give 2 and this will also give 2. So highest boiling point will be the one which gives largest number of particles. Now in comparison to 0.0 1 m solution of glucose, a depression of freezing point of 0.01 magnesium chloride solution is. Now both have same concentration, right? One of them is glucose and one of them is magnesium chloride, right? Will the depression in freezing point of both the solutions be same, or will it be twice, or will it be 3 times or 6 times?
3 times.
3 times. Very good. Did all of you understand this? Why it is 3 times? Because magnesium chloride will give 3 moles of ions, right? So 0.01 will work as 0.03. And this will not ionize in solution. So it is about 3 times. Very good. Then 12th one, an unripe mango is placed in a concentrated solution to prepare a pickle. Shrivels because. Tell me.
It loses water due to reverse osmosis.
Why reverse osmosis? Reverse osmosis is when we apply pressure to prevent osmosis. Here osmosis will, it loses water. What is it?
Due to osmosis.
Due to osmosis. It loses water. It shrinks, so definitely it loses water due to osmosis. Reverse osmosis, Vaishnavi, it is when you artificially give pressure to prevent osmosis. That is only when you are doing purification of water. So you want pure water to move from the concentrated solution towards the dilute. Otherwise, dilutes from dilute, it goes towards concentrated, right? So that is why.
Yes, ma'am.
Then 13th, at a given temperature, the osmotic pressure of a concentrated solution of a substance. At a given temperature, the osmotic pressure of a concentrated solution of a substance is
Higher than the dilute solution.
right, is higher than the dilute solution. Okay, larger the number of particles, greater will be the osmotic pressure. Okay, so osmotic pressure of 1 molar solution of glucose will be less than the osmotic pressure of 1 molar solution of sodium chloride. Okay, sodium chloride will have more particles. So wherever there are more particles, there will be more osmotic pressure. Which of the following statements is false? Units of atmospheric pressure is units of atmospheric pressure and osmotic pressure are same. It is true. We have to find the false statement, right? In reverse osmosis, now Vaishnavi, listen carefully. In reverse osmosis, solvent molecules move through a semi-permeable membrane from the region of lower concentration of the solute to a region of a higher concentration. Solute particles, they never move. Okay. Solvent particles, they move through the semi-permeable membrane, true, from a region of the lower concentration of the solute to a region of a higher concentration of the solute. So where in reverse osmosis, where should the solvent move? It should move from a region of higher concentration towards the lower concentration, right? Because you are purifying water. If you can think of that, you are purifying water. So water molecules should move from the region where there is impurity towards where there is pure water, right? So this statement is false. Okay, you can read the rest of it also. Value of molar depression constant depends on the nature of the solvent. Yes, each solvent has a different. Yeah, tell
For
me.
all, will the solvent move from lower to higher pressure?
See, when
Like
it is
lower to
simple
higher concentration.
osmosis, see, when it is simple osmosis, okay, the solvent normally where this is dilute solution, right? And this is concentrated. So if it is osmosis, what should happen? solvent should move from dilute to concentrate, right? In reverse osmosis, what happens? Solvent moves from concentrated to dilute, reverse osmosis. So here,
okay, ma'am.
okay. Value of Henry's constant Kh increases with increase in temperature. Tell me. Value of Henry's constant Kh increases with increase in
Remains
temperature.
constant.
It
Decreases with increase in temperature.
See, it is constant at a particular temperature, but when I increase the temperature, it increases with increase in temperature because the solubility of the gas decreases with increase in temperature. So Kh, value of Kh will increase with increase in temperature. Okay. Answer is 17. Then value of Henry's constant is, now this one you should answer correctly. I have emphasized this. Tell me, it is greater for gases with higher solubility or is it greater for gases with lower solubility? Somebody? What is the formula? It is P is equal to KH into X. So KH is equal to P by X. If X is representing the solubility, mole fraction of the gas, then they are inversely proportional, isn't it? So KH, if KH is high, solubility is low. If KH is low, solubility is high, right? So you can see greater for gases with higher solubility, that is wrong. It is greater for gases with lower solubility. This is the correct answer. Understood, all of you? You should be thorough with this chapter. There are 10 marks questions which come in the board exam. This year we are preparing for the board exam, so you have no option to keep looking at the questions, answers. If you want to see these questions anyway, you will get to see this PPT again. It will be there. You can go through it again. You can take screenshots, whatever you like, you do. Now 21. This is a little more reading type. Please read and answer. This is like a longish question. Tell me. On the basis of information given below, choose the correct information. So in bromoethane and chloroethane, the intermolecular interactions of AA and BB type are nearly same as AB type. Okay, what does it mean? This information A, this, what does this show? That A is an ideal solution. This is an ideal solution. Okay, in ideal solutions, what happens? AA and BB interactions are equal to AB interactions. Okay, so that is the ideal solution. What is B? In ethanol and acetone mixture, AA or BB type interactions are stronger than AB interactions, right? So this is positive deviation. Right? If AB type of interactions are less, AA and AB interactions are more than AB interactions, then it is a positive deviation. In chloroform and acetone mixture, AA or BB type interactions are weaker than. So this is negative deviation. So the new interactions are more and the old interactions were less. In this one, the old interactions are more, the new interactions are less, right? So what does it show? B and C follow Raoult's law? No, these two are non-ideal. So B and C follows Raoult's law. This is wrong. They don't follow Raoult's law. Solution A follows Raoult's law. This is correct. B will show negative deviation. No, B shows positive and C shows negative deviation. All right. So this is wrong and this is wrong. So what is the answer? 2. Okay. Now look at the next question. See it carefully. Okay. 2 beakers of a capacity of 500 ml were taken. One of these beakers is labeled as A, was filled with 400 ml of water, and beaker B was filled with 400 ml of 2 molar solution of NaCl. At same temperature, both beakers are placed in closed containers of same material of same capacity. At a given temperature, which of the following statements is correct about the vapor pressure of pure water and that of NaCl? Just read and answer. If you don't answer, then don't understand, then I'll explain. Who will tell me the answer? Now here there is only pure water, right? Here there is sodium chloride solution. Tell me which will have higher vapor pressure. What is the vapor? Is vapor pressure of water more than vapor pressure of NaCl? Or is vapor pressure of NaCl more than water? Tell me. Pure solvent. Here it is pure solvent. Right? And here there is solution. Hari Raghav will answer now. Hari Raghav, tell me which will have higher vapor pressure. Hari Raghav, are you there?
Ma'am, is it solution NaCl?
Which will have higher vapor pressure? I didn't hear you.
Ma'am, is it NaCl?
No. See, I
Ma'am, is the
explained.
vapor pressure equal for both?
How can it be equal for both?
Ma'am, water is a pure solvent and
So when there is a pure solvent,
NaCl
what
is
happens?
non-volatile solute.
And it's a non-volatile solute. Very good. So which will have higher vapor pressure?
Ma'am, when a non-volatile solute and solvent mix, the vapor pressure of the solution is equal to the vapor pressure of the solvent, no, ma'am. So it is both of them will be equal, no, ma'am.
No, that is true. But there is additional thing which happens. See, you are in Sai Kalyan, you are saying the right thing. Here, the more you are saying the vapor pressure of if the amount of solvent is same, then the vapor pressure should be same because the vapor pressure of the non-volatile solute will not add to the vapor pressure. But the non-volatile solute causes depression in lowering of vapor pressure, isn't it? It also causes lowering. It will not add to the vapor pressure, but it causes lowering of vapor pressure, right? So the vapor pressure in container A is more than the vapor pressure in container B. Okay, so the non-volatile solute does not add to the vapor pressure, but because of the presence of a non-volatile solute, the pure solvent is not able to vaporize. I continuously I was showing you this thing, no, that there is a container in which I have a liquid and I add non-volatile solute on the surface, it's not able to evaporate. So what will happen? There is a lowering of vapor pressure. What does lowering of vapor pressure mean? It means that when I add a non-volatile solute to a solvent, the vapor pressure of a pure solvent is reduced. Did you all understand that? So answer is 1.
Okay.
Okay. See, if the non-volatile solute was such that it was not affecting the vapor pressure, then your argument was right, Sai Kalyan, that if the volume of the solvent is same, the vapor pressure should be the same, because the non-volatile solute does not add to the vapor pressure. It does not add, but it reduces the vapor pressure of the pure solvent. Okay, so that is what happens when I add. In case of gases, yes, the vapor pressure of the solution is equal to the sum of partial pressures of both of them. Here, one of them, the partial pressure is 0. So it should be equal to the vapor pressure of the solvent, but the vapor pressure of the solvent itself is lowered, right? Whatever is the vapor pressure of the solvent, that itself is lowered. That is. Okay, now one by one, you match the following. All of you now, 5 of you are present. All of you should answer. Hari Haran is also there. I didn't hear you, Hari Haran, at all. Hari Haran? Now to this question, you have to answer one. There are 6 subparts, so you answer one. What is a saturated solution? You have to match the following. All the definitions are there. All of you read and match it. So saturated solution is what?
Ma'am, is it option D?
D, ma'am.
It is, yes, D, right? D. Okay. Saturated solution is one which contains maximum amount of solute which can be dissolved in a given amount of solvent at that given temperature, right? Then what is a binary solution? Sanjay, you answer. What is a binary solution?
Yeah, ma'am.
No, binary means 2. So what is a binary
So
solution?
C.
Yes, C. Solution with 2 components. Right. Then what is isotonic solution? Hari Raghav. What is isotonic solution?
Ma'am, is it DA, ma'am? Ma'am, A.
Yes. Solution having same osmotic pressure as a given temperature. Very good. Then what is hypotonic solution? Chitra?
Ma'am, option B.
Hypotonic solution whose osmotic pressure is less than the other. Very good. Then Sai Kalyan, solid solution.
Ma'am, yes, ma'am.
Yes. And so obviously this is the last solution whose osmotic pressure is more than the other. Okay. Now all of you one by one. Okay. I will, only those whom I asked should answer. Okay. So first one, Hari Raghav, mass percentage is equal to what?
Ma'am, it's D, ma'am.
It is D. Very good. It is D. Right. Volume percentage. Sanjay, what is volume percentage?
No, volume percentage is volume volume of solute divided by total volume of solution into 100.
Yes, very good. Excellent. Mole fraction. Hari Haran. Mole fraction.
B, ma'am.
B, very good. Excellent. Then Chitra, molality.
Ma'am, E.
E. So sorry, Sai Kalyan. Now I couldn't give you anything. It is A. All right. So you know, so it was just a practice.
Could you show me the answers, ma'am?
Okay. So now, children, do you have any more doubts that you?
Ma'am,
Huh.
can you show me the first match the following? I want to see something.
Okay. Now, children, any other question, any other type of question? Do you have a doubt? I will give you 5 minutes to ask doubts. Otherwise, we will do some more MCQs. Of this chapter, do you remember? Do you have any doubt? No doubts?
No doubts.
Okay, very good. So now I will give, there are 10 minutes. In 10 minutes, I want you to do 3 questions. Okay, so all of you be ready, get set. So I'm going to write the questions. Unfortunately, I didn't write and keep. So first question is, you have to calculate the freezing point. Calculate the freezing point. Of 1.9 grams of MgCl2. Molar mass is 95 grams per mole. Dissolved in 50 grams of water. Right? And assume MgCl2 undergoes complete dissociation. Okay, now please tell.
Ma'am, what is the K?
Yes, I should tell you. Kf is equal to 1.86 kilogram Kelvin per mole.
Ma'am,
Hmm.
is it 7,001.5?
What is it?
7,001.5.
How can you get? No, 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 no. What did you do?
Is my answer similar to that, ma'am? Or it's nowhere near that real answer?
Nowhere, nowhere, nowhere. You have to find the freezing point. It's nowhere near. See what you have to do. It is delta TF. It
Ma'am,
is,
ma'am, is
yeah,
it
tell me.
um,
Minus how much?
ma'am, is it minus 272.256?
Yes, you are close. Answer delta TF, how much did you get? Delta TF is 2.2 Kelvin. See here, TF is equal to I into KF into WB into 1000 divided by MB into WA, right? Complete dissociation. So MgCl2 on complete dissociation, what will be the value of I? It will give Mg2 plus 2Cl minus. So I is equal to 3, number of ions after dissociation. So 3 into 1.86 into 1.9 into 1000 divided by molar mass is given as 95 grams per mole. So that is 95 into 50 grams of water. So if you do calculation, what will be TF?
Ma'am, is it,
Sai Kalyan?
ma'am, is the final answer minus 270.76?
Yes, 270 point. Correct. Okay, so delta TF, first find out delta TF, you will get about 2.2.
2.23.
Yeah, 2.23. Answer TF will be equal to. Sai Kalyan, did you understand your mistake?
Yes, ma'am.
23 Kelvin. Okay. So TF, that means of water. This will be 273 minus 2.23. So that will be 270 point something. Approximately 270 Kelvin. Did all of you understand what we are doing? Okay, I want all of you to do well, at least for your solutions. Now tomorrow I'm going to do similarly a lot of questions on halogens, haloalkanes. So that also I'll do MCQs and assertion reasoning and some conversion questions. Okay, so that when you have a test, you are all thorough with it. All 6 of you or 7 of you, all of you should get more than 90% marks in your test. 80 mark test is there. So you should do well. Okay. So Hariharan, Sanjay
Thank you, ma'am.
always.
Thank you.
Okay, then see you. Bye.
Thank you, ma'am.
Bye.
Thank you.
You're welcome.